Good morning. Today's notes are 8.1 associated with our text, and the topic is simplifying rational functions. And this is both our notes and our assignment. So we're going to take a look here, beginning a new unit, and it's all about rational functions. And rational just means a number that can be written as a over b. So fractions is how we typically think about rational functions. So as you can see, we have all these different examples where we have our fraction line. So simplifying fractions we're familiar with when we think about if we have 4/8 and we look for the common factor. Greatest common factor here would be 4, and we would divide each numerator and denominator by 4. 4 divided by 4 is 1, 8 divided by 4 is 2. And many of you might think, well, that's simple, I understand, and we're going to see the same concept applied here, and now that we're dealing with polynomials in our numerator and denominator. So when looking at a rational function, we want to look to see if there is a polynomial with more than one term, if there is a greatest common factor that we can factor out. And between 63 and 18, we can see that 9 would be the greatest common factor. And then between x squared and x would be the greatest common factor. 63 divided by 9 is 7, and x squared divided by x is x. And then 18 divided by 9 is 2, x divided by x is 1. So now we see the factored form of that denominator. So I can kind of cross that out so it doesn't get in the way. And now I'm looking in the numerator and denominator to look for the greatest common factor. So between 63 and 9, we just kind of discussed that one. 63 and 9 have a common factor of 9. So we're going to divide by 9. So our coefficient would be 63 divided by 9 is 7, and 9 divided by 9 cancels out. And next we're going to look at the x's. So we have an x cubed and an x in our unique factors. So between x cubed and x, we have an x in common. So again, if we divide by x, divide by x, here we have the x's canceling out. X cubed divided by x is x squared. And what's left in the denominator is our 7x minus 2. Now some folks might be tempted to cancel out 7 and 7, but keep in mind 7 is not a factor of the entire denominator, so it does not qualify to be reduced. Next one, number 2. So we're going to look, here's our binomial, so we'll look to factor out the greatest common factor. 14x and 10 have a greatest common factor of 2. So 14 divided by 2 is 7. There is not an x in common, so we're leaving that x there. 10 divided by 2 is 5. So we're going to cancel that out. And now we look to reduce in the numerator and denominator. The greatest common factor between 12 and 2 is 2. So we'll divide by 2. 12 divided by 2 is 6. There are no x's to be canceled, so x squared remains in the numerator. And these are now canceled out, so our denominator is 7x plus 5. Number 3, factoring the numerator. Greatest common factor here is 4. Dividing 4x by 4 we get x. Dividing 40 by 4 we get 10. And now you'll notice between the numerator and the denominator, the greatest common factor is actually this entire binomial, x minus 10. So we can actually cancel that whole thing out, leaving us with 4 as our final simplified answer. Number 4. Similar to our previous problems, 14x and 18, we're looking to find our greatest common factor. 14 and 18 have a greatest common factor of 2. So 14 divided by 2 is 7. There are no x's in common, so that remains. 18 divided by 2 is 9. And now we look to reduce the numerator and the denominator with their greatest common factor being 2. So 7x plus 9 in the numerator and 9 in the denominator. Number 5, x plus 3 is already simplified. They don't have any common factors, x and 3. Now we have a trinomial in the denominator, so we're applying our factoring strategies, looking to find two numbers that multiply to get negative 27 and add to get negative 6. So let's see, 9 and 3 multiply to get 27, so 9 times 3, and the greater of the two needs to be negative since they're going to add to get a negative. And negative 9 and 3 is negative 6, so that worked out on our first try. So recall we would just write that in factored form, x minus 9, x plus 3, and that is our simplest version of factoring a trinomial since our lead coefficient is 1. And now we see, similar to number 3, we're actually going to be able to reduce by a factor of x plus 3, leaving a 1 in our numerator and the x minus 9 in our denominator. Number 6, we have our binomial in the denominator, so 35 and 49 have that greatest common factor of 7. R is the only variable in the denominator, so it will stay. 35 divided by 7 is 5, and then we'll keep our R. 49 divided by 7 is 7. And looking to reduce from numerator to denominator, 42 and 7 have a common factor, greatest common factor of 7. 42 divided by 7 is 6. Just cancel out, and we are left with 5r plus 7. We'll do two more. Number 7, we have x minus 2 over 5x squared minus 10x, so looking to factor this denominator, the numerator is already as simple as it can be. In the denominator we have a 5 in common, and we also have an x in common, greatest common factor being 5x. 5x squared divided by 5x is x, and then 10x divided by 5x would just be 2. And here we have the x minus 2's cancel, and we have 1 over 5x. Last one, looking to factor our trinomial with negative 72 and 1, trying to find two numbers that multiply to get negative 72 and add to get 1. So we'll try two numbers that are relatively close together. So let's see, 9 and 8. So ending in a positive sum will make the 8 negative. They add to get 1. So our numerator can be factored into n plus 9n minus 8. Now here's an interesting situation. The 8 minus n and the n minus 8 are very close, but they cannot cancel as is. However, we could rewrite the 8 minus n if we simply factored out this negative sign. So we factor out a negative 1. 8 divided by negative 1 is negative 8. Negative n divided by negative 1 is n. And now we have the same thing. These are just in a different order. So we will rewrite that with our positive n first, and then our negative 8 second. And now you can see very clearly that we have the common factor of n minus 8. So I'm going to kind of cross out my steps along the way so I can see clearly the n minus 8's cancel. We're left with n plus 9 over negative 1. We don't need to keep the negative 1 in the denominator. We can simply rewrite that. Dividing each term by negative 1, we can write that as negative n minus 9. It'll be our most simple answer there. Now, one thing we have not yet addressed is this element of our instructions that say state the excluded values. So you recall, denominators cannot be 0. Cannot have a 0 in the denominator. And sometimes we are completely canceling out an x in the denominator. And when that happens, we need to be sure and indicate the values that are not allowed to be used in these functions. So if x got canceled out, let's figure out, we set it equal to 0. Whatever got canceled out that has an x in it, we set equal to 0. Now in this case it's very straightforward. We cannot have a 0 for x, or the entire denominator would become 0. And you can see if we go back to that original denominator of 63x squared minus 18x and plugged in a 0, we would have a 0. Not allowed. Now when we just have a rational number or an integer value that cancels out, we won't have to worry about any excluded value. So the 2, we don't have to worry about. Now when the x minus 10 is canceled out entirely, we have to set that x minus 10 equal to 0. Add 10 to both sides. So x cannot equal 10. If we plugged a 10 in here for x, the entire denominator would be 0, which is not allowed. Here we don't have to worry. Here we have the x plus 3's that canceled, so x plus 3, setting that one equal to 0, subtracting 3 from both sides. So x cannot equal negative 3. 7's cancel out, nothing to worry about there for excluded values. Here the x minus 2's cancel out, so x minus 2 can't equal, we're setting that equal to 0, adding the 2 to both sides, so x cannot equal 2. And lastly, the n minus 8's canceled, so n minus 8, setting that equal to 0, n equals 8 would make this denominator clearly 0, not allowed. And so these are called our excluded values. So again, this is simplifying rational functions. These are our notes, and then on the back you will have some problems to do on your own.